Okay, so today we're going to be looking at the properties of logarithm. So remember, a logarithm is the same thing as an exponent, so all of our exponent rules are going to apply. So our first one we're going to look at is the product rule. So if we have b to the m power times b to the n power, since they have the same base, we add our exponents. And the same thing applies for logarithms. So log base b of mn is the same thing as log base b of m plus log base b of n. So if we look at this, log base 4 of 4 times 5, we can rewrite as log of base 4 of 4 plus log base 4 of 5. What's nice about doing these expansions is then we can simplify further, because 4 to what power is 4? Well, that would be 1. So 1 plus log base 4 of 5. So looking at b, we have log of 10x. So we can break this apart, make this log of 10 plus log of x. And if we look at log of 10, remember the base here is just understood to be 10 when there is nothing written. So 10 to what power is 10? And that would be 1 plus log of x. Looking at c, we have log base 6 of 7 times times 11. So this becomes log base 6 of 7 plus log base 6 of 11. And we can't write 7 or 11 as some exponent of x, of 6, so that's going to be our expression. And then d, we have log of 100x. We can rewrite this as log 100 plus log x. So remember, we have this understood 10 as our base. So 10 to what power is 100? That would be 2 plus log of x. Okay, so our second rule we're going to look at is the quotient rule. So when we are dividing, remember we subtract our exponents of like bases. So again, when we're dividing a log on the inside expression, we're going to expand it and make it subtraction. So log base 7 of 19 divided by x becomes log base 7 of 19 minus log base 7 of x. And that would be our expanded expression. We can't simplify that any further. Looking at b, we have the natural log of e to the 5th divided by 11. So the natural log of e to the 5th power minus the natural log of 11. Remember, the natural log of e, those cancel, so we're left with 5 minus the natural log of 11. Log base 2 of 32 divided by x becomes log base 2 of 32 minus log base 2 of x. So 2 to what power is 32? That is 5 minus log base 2 of x. And looking at d, we have the natural log of e cubed divided by 7. That becomes the natural log of e cubed minus the natural log of 7. The natural log of e, those cancel. We're just left with the exponent of 3 minus the natural log of 7. Okay, so our third rule we're going to look at is the power rule. And that says that when we have b to the m power to the n power, we can multiply those exponents. So here what we're going to do with power rule is we're going to take that exponent that's on the inside and we're going to move it to the front of the log and multiply. So an example of that, looking at a, we have log base 5 of 7 to the 4th power. And that's the same thing as 4 log base 5 of 7. So we take that exponent and we just move it to the front. Okay, so if we look at b, We have the natural log of the square root of x, so we can rewrite that as the natural log of x to the 1/2 power. And that 1/2 power is going to swoop to the front, so we have 1/2 natural log of x. And then looking at c, we're going to take this exponent of the 5 and we're going to move it to the front. So we have 5 log of the quantity of 4x. And if we wanted, we can combine the two properties that we know. So we just use the power rule. And now we can use the product rule for this 4x. So we have 5 times the quantity log of 4 plus log of x. And then distribute that 5 in front. So the thing to remember is if you have parentheses, you have to distribute that exponent to both terms, which is why we're going to write the 5 in front of both terms of our log. So that's called expanding each logarithmic expression. So that's what we're going to use on these next few examples, is expanding using multiple properties. Okay, so if we look at a, we have log base b of x squared times the square root of y. Since we're multiplying, that's the same thing as adding. So log base b of x squared plus log base b of the square root of y. And then we can move our exponents. So here the 2 is going to move to the front. So we have 2 log base b of x plus, so the square root of y, we can rewrite that as y to the 1/2 power. So our exponent 1/2 is going to move to the front of log base b of y. Okay, looking down at b, we have log base 5 of 125 divided by the square root of x plus 1. So that becomes log base 5 of 125 minus log base 5 of the square root of x plus 1. I'm going to go ahead and write that as the quantity of x plus 1 to the 1/2 power. And then we can simplify this further. So the log base 5 of 125. So 5 to what power equals 125, and that would be 3. Minus, and then move that exponent to the front, 1/2 log base 5 of x plus 1. Looking at c, we have log base 6 of the cubed root of x divided by 36y to the 4th. So here's the thing to remember. So if we're looking at addition and subtraction, our numerator will always be addition, and our denominator will always be subtraction. Okay, so here we're going to do a couple things. So if we look at the numerator, we have log base 6 of the cubed root of x, which I'm going to rewrite as x to the 1/3 power. And now we have two things in the denominator. We have 36 times y to the 4th. So we have minus log base 6 of 36, and then also we have minus log base 6 of y to the 4th. Okay, so since we're multiplying two things in the denominator, we're going to write it as two separate logs. And now we can simplify. So we can move our 1/3 to the front. So we have 1/3 log base 6 of x minus log base 6 of 36. 6 to what power is 36? And that would be 2. Minus log base 6 of y to the 4th. So the 4 is going to move to the front. So we have minus 4 log base 6 of y. And then on d, log of x squared y divided by z cubed. Break it apart. Remember, anything in the numerator is going to be addition. So we have log of x squared plus log of y minus log of z cubed. And then we're going to move our exponents to the front. So we have 2 log of x plus log of y minus 3 log z.